I'm a solutions engineer at Esri Eastern Africa, supporting the commercial industry. So today we're going to cover data-driven site inspection with ArcGIS, and our main goal is to learn how the integration of ArcGIS enables construction authorities to improve project oversight, allowing for better tracking of construction progress across various regions. So we want to see, or rather know, what these construction authorities do, or rather what their mandate is. And their key mandates are registration of local and foreign contractors. They do accreditation of construction workers. They do registration of projects. There is the renewal of practicing licenses. There is research and also training and capacity building for the key players in this particular industry. And the biggest mandate is compliance and compulsory site inspections. But they are encountering challenges even as they strive to deliver to the citizens, or rather meet their mandate. And these challenges are such like resource intensive. So the process is resource intensive and requires resources such as staff, vehicles to be stationed throughout the area of operation. You'll find that some projects are in dense or remote areas, and they may be missed during quality assurance inspections. It's also very time consuming looking for ongoing projects, and there is that aspect of manual processing, or rather manual recording of these particular projects. So all these problems are spatial if you think about it, and we are looking towards achieving a sustainable future, which basically starts with geography. So our problems could be social, they could be economic, they could be environmental, and this particular one is environmental and both economic, looking at infrastructure, which forms part of the building or the construction industry. So geography provides the science and the fundamental language for us to be able to curb such problems and address these needs by organizing and integrating all the factors. So GIS, a key part of geography, is used to enable these key players to carry out their activities such as data collection. Of course, when site inspections are being done, there is a form that is being filled, and that is an aspect of data collection. And there is the location aspect of it. And at the end of the day, we want to see where have we covered in terms of inspection by visualizing and mapping these areas that we have visited, and also just planning ahead for your field work and know where you're going. Then we do our analysis after we gather this information and see which areas are they, do we have dynamic growth in terms of building and construction, which areas do we need to concentrate more, which areas do we have to take action on. And this leads us to planning. And finally, there is the decision-making part of it, where we need to do the compulsory monitoring throughout the project life cycle and take action by reporting and enforcement. And this improves how we create our future. Eventually, we create understanding, explore alternatives, find solutions, and take action. So ArcGIS as a system is a major component of GIS that we're talking about here, and it's open and interoperable. We have quite a number of applications out there that are being used in the architecture, engineering, and construction industry, or in the construction by construction key players. And ArcGIS supports and leverages multiple open initiatives, such as the open standards. It supports open data. It's an open architecture that is interoperable and integratable. It supports open science and accessibility as well. Just to mention but a few of these technologies is the Overture Maps Foundation, the EarthCube, and OGC standards which the system is compliant. Further down, we can see that we have multiple integrations going on within the system, and the biggest one used in the construction industry is Autodesk. Autodesk is a partner of Esri, and we have the Autodesk Civil 3D that is integratable with ArcGIS through ArcGIS Pro, ArcGIS Online, and ArcGIS Enterprise. We have the InfraWorks, we have Revit, which bring in different formats that are tied to the different disciplines that we have within the industry. We have the Autodesk AutoCAD connector. We have the Autodesk BIM 360 cloud construction that ties or links or integrates directly to ArcGIS Online and ArcGIS Pro. And you can always read these files within ArcGIS Pro, as we will see later in our demonstration. And this integration supports a number of data sets that can be read within the system. We have imagery, we have CAD, we have vector data, and you can also integrate this with IoT. You can work with unstructured data such as PDF, drawings such as JPEG. You can be able to view this within the system. We have tabular format data, 3D, and LiDAR as well. ArcGIS system for AEC, or architecture, engineering, and construction. Just what exactly is this? So looking at project management and delivery system, we have the environmental remediation and restoration, design and engineering collaboration between key players. We have construction management and logistics, because in construction, of course, logistics is a major bit where you're sourcing materials from one end to another. Then there is the client engagement and collaboration. We have a number of capabilities that are supported by our system, and this enable you to understand, be able to perform analytics, draw insights, and eventually model and have prediction. And the core internal system, GIS system, is ArcGIS, that gives you access to mobile applications. You can get web applications. You can get access to our enterprise platform and software as a service, which is ArcGIS Online, that provides you with the portal for engagement and also content management. And all these are enabled by our different kinds of user types. We have the viewers, the contributors, mobile workers, creators, and professionals who are working within this particular industry. So in the construction industry, projects rule, and AEC think in a way of projects and not necessarily enterprises typically. These are a list of projects that we are looking at: site remediation, we have roadway design, transportation planning, disaster response, construction planning, and so on and so forth. ArcGIS is a project system that supports all these workflows within the construction industry. And looking at this central repository, we have a number of sub-projects or subsystems that integrate with this overall project system. The likes of smaller point solutions, there is Autodesk, we have the environmental data management system, we have the enterprise analytics system, the enterprise resource planning system, ERPs, and also SharePoint, basically a system for document management as well. So how exactly does our system supports this industry? We have the modern GIS deployment in AEC that creates a connected data environment. Think of reality mapping and field data collection. When we are doing the inspection, we are picking information from the field, and this is field data collection. And before we go to the field, really, think of data-driven workflow where you've been able to identify where these buildings are, which buildings are new this particular time. Maybe periodically you're looking at new buildings monthly, quarterly, or weekly, and you're able to know that we were able to go to the ground, put an X on this particular building, but again, it has construction is ongoing, and right now we can see that there is an advancement in terms of number of floors. Then you have to go back to the field and gather information, more information, and take action. There is environmental urban planning and engineering design, where we are interacting with different professionals within the industry, and during the project registration, they are supposed to provide us with these particular documents. In what format are they bringing the documents? How are we going to get these documents in the system? So this particular module enables us to collaborate, brings out strongly the ability of ArcGIS as a system of engagement. Then we have visualization and simulation. We have virtual reality, animation, Unity. We can also see construction rehearsals, and this can be visualized in 3D, which is an immersive way of visualization. Then finally, there is project management and delivery that entails project delivery. And just to mention but a few components of this particular module are our ArcGIS GeoBeam, and you could have a story map showing the same, and for indoor navigation, have your ArcGIS indoors, and this is integrated with Primavera P6. Imagery is a major part of this particular solution. So our imagery capabilities span across reality mapping. You could be flying drones to see how much development has gone on in the ground. We are able to perform analysis such as change detection and be able to pinpoint or extract building footprints and see what was there before or what has been added on the ground, and be able to take action. We're able to visualize this using a couple of software or applications. Then there is the data management bits, where you're able to see and store this data that conform with the open standards. You can also use tile and dynamic services, and these are massively scalable. So what is new and improved? I'll just highlight the Planet ArcGIS Pro add-in that enables us to plug into the Planet imagery, even as we create or rather do our analysis, and we're able to do change detection and extract these buildings. Then we can always bring this output to the ArcGIS environment, and we can also access base maps, Planet base maps on ArcGIS Pro, and get to see changes that are taking place on the ground. A glimpse of how this exactly works. So we can see that we have an 8-week prior weekly mosaic. We can see a building propping up after. Then we can see that after a month, we can see progress. Then in the month of June, there is remarkable progress from what we had previously. And finally, we can see that we have a complete building. So comparing this picture 1, 2, 3, and 4, these are extracts of Planet imagery. And we can see that there are no marked changes or remarkable changes on Google satellite image. So you are to go to imagery would be Planet imagery, which is has a very high temporal resolution that you can use to actually track changes on the ground. When it comes to fieldwork, we have been able to identify these buildings. We want to do something about it. Of course, we won't just sit and warm our seats. We'll have to go outside. And that brings us to the point of field to office workflows, where we want to plan and coordinate and actually in the office, we are able to prepare maps, forms, and also projects, visualize this, analyze and prioritize our work, and see which particular area needs our immediate attention. Then we are able to prioritize in terms of workforce management. Then in the field, we are able to send our field crews, they complete their prioritized work requests, and they're able to view and communicate status and also progress of this work that is going on in the field. And this involves three key players. We have a GIS analyst who's seated at the back office, and they're able to prepare all these maps and forms ready for our field work. We have the supervisor knowing which areas are to be visited on site, and they're able to assign roles to the different mobile workers. Then finally, we have these field workers who are going to be dispatched to the field, and they will be able to gather this information. So really, what are the benefits of this particular solution? At the end of the day, we'll be able to achieve enhanced site monitoring. We'll be able to curb unapproved construction activity. It enables users to have efficient resource allocation. It supports data sharing and collaboration with other agencies. So thinking of construction authorities, they work with other bodies and they are able to collaborate. Then it enables them to adopt latest technology and see what's new in the construction industry to just enable them to enhance their workflows. And this saves on time and also resources at the end of the day. So with that, I'd like to do a quick demonstration on the same, just to show us the workflows and how integrating ArcGIS in building site inspection saves on time and ensures efficiency in terms of workflows in this particular field. So allow me to share another screen. Victor, confirm that you can see my screen. Yes, so starting on the collaboration bit, we have talked about project registration and how files are being shared, even as the projects are being registered. We have ArcGIS GeoBeam that can be accessed first on your ArcGIS Pro. So you create a new connection and connect to the Beam Cloud connection. And here you're able to access files that are uploaded from that end. So from our Beam Cloud connections, we have one connection and we can see a number of projects here and project files as well. So our project files are arranged in terms of disciplines such as architecture. We have MEP, that is mechanical engineering, and plumbing. We have survey documents as well. And all these documents, thinking of all these players that are involved in a construction before it actually begins, and they are needed to share their documents, we can have the documents arranged in this manner, and this can be accessed within ArcGIS Pro, and we can actually visualize in both 2D and 3D as well. Then once we have this file, we can always share the files to our portal, be it your enterprise or your ArcGIS Online, and you're able to do further analysis here on the portal. So what you're seeing on the screen, let me reshare a new screen. So what you're seeing on the screen is the GeoBeam application on ArcGIS online, and we're able to see the same structure. We're actually able to see documents that are attached to this particular project. So I am able to navigate to this particular building, click on a point. If there is a document there, then I am able to link it. And as you can see here, here's my document. I can interact with it. I can do a measure. I can also do area, or I can delete that, which I've just added. I can go ahead and look at the document browser, view it in 2D or 3D. I am able to look at particular settings such as configuration, navigation, and appearance, and so much more. So this is a way of document management, and we're able to view this particular documents within this system. And besides that, apart from collaboration, we are able to do analysis here also on our ArcGIS GeoBeam, and we have the daylight effect. We can see sun position by date and even shadow. Let me check that on. Then we can just look at what was there on 15th March and see. In terms of shadow, we can even change the time and see at 6 p.m. it was completely dark, 12. So you can do even this with future scenarios. You can go ahead and simulate weather. You can also see the shadow cast. Where will the shadow be casted within a particular time? We are able to also do an analysis for line of sight. For instance, if we wanted to put CCTV cameras on this building, we want to see if we put it maybe at this particular point, then what would be the coverage be? So we have that analysis bit that we can do. We also have the Building Explorer, where we can actually see our building in the different layers. So we can check the architectural and see. We can uncheck maybe electrical and mechanical and see. We can choose to see piping alone of this particular proposed construction. So this actually helps you, whoever is at the back office and they are looking at this particular documents, to be able to approve. They're able to perform such analysis, and at the end of the day, they're able to draw insights from them and make informed decisions. So that is our GeoBeam. So now, let's imagine we have a few projects that have been registered, but what about those that haven't been registered yet? So those that have not been registered and yet there is construction going on in the field, how exactly are we able to tell that there is something going on the ground? We are able to use machine learning models, and this is a snippet of the analytic feeds of planet imagery, and we're able to detect buildings for particular dates. This is specifically for Nairobi. We have buildings detected on the 12th, from 17th March, sorry. Yeah, we have quite a number. So we can see that we have buildings for 12th June 2023. There is one for 5th, and this is a difference of 1 week. Before then, there was buildings for May and 15th May. So depending on the time period in which you're looking at these changes, it could be monthly, it could be quarterly, it could be weekly. Then we are able to detect these changes. So for instance, we can take a quick look at buildings detected on 12th June of 2023. And we can see that we have 15 buildings that were detected then. And we are able to extract these buildings. So once I select it, then we can review and export, detect, and see if we have a positive or a negative, false positive, or indeed there was a change or a building that was detected on the ground. So we can see that right here, this is in May, we can see construction starting. Then in June, we can actually see a couple more buildings at this particular area. So if we select that, then we actually are have pinpointed a change. Then we can export all these detected buildings by exporting all, or we export the reviewed detections. We export this in a file such as GeoJSON, and we are able to consume this within our ArcGIS Pro. So next, I'll go back to my ArcGIS Pro. Then we can see that we did have a number of buildings that we detected and were able to export. We have buildings that we observed in the month of May, then 5th and 12th of June in the year 2023. So we can clearly see that in these particular areas in Ruaka, we can see we have a building that was detected. We have a building in Roysambu from our change detection. We have another one in Kasarani Mwiki, and we're able to see those changes. Then now we need to take action. What do we do then with these buildings? Remember, this is at the back office, and most probably this is a GIS analyst who is looking at these changes, and they are able to advise the compliance team on where exactly to give priority or where exactly to go and perform these particular inspections. So before they go to the field, we need to inform the management that in our analysis, this is what we saw, and action needs to be taken. So we can quickly show that in a dashboard. And we can see the number of buildings that were detected. We have a total number of 53 buildings that were detected in this particular area. Then this dashboard can be filtered using various sub-counties within Nairobi. We can see Lang'ata, how many buildings were detected in Lang'ata? There were 12. And some of them were detected two were detected in 22nd May. We have a number that were detected on the 12th of June, and some were detected on the 19th of June. We can also filter by detection date and see how many were detected in May. There were 10 buildings in Ruaka, Kasarani Westlands, Dagoretti South, and Lang'ata. So we can see all this, and based off this information that we have, then we are able to have a data-driven kind of view and be able to see which areas should we prioritize in terms of interventions. So we have this already, and we know where we really want to go, then now we need to send a team to the field. We have a field crew that we are working with. So we go give them assignments. If it's demolition that we want to do, or routine building inspection or compliance checks, we are able to give these assignments. So an assignment that I am interested in is this one that was given like 8 minutes ago. We need to do a routine building inspection, right? So we go to this particular place on the ground. This is in Roysambu, Nairobi. We are using ArcGIS Workforce to be able to give assignments and manage our workforce even as they work in the field. So I've given assignments and I want to send someone to the group, to the field, to be able to do this inspection. I'm sending Joyce, that's me. So allow me to share another screen with you. So I've been assigned this task and I need to go to the field. So I start my assignment and I'm supposed to do a compliance check in Kangemi. Then, so now I have a form that I need to fill. This has given me a notification that I actually have work to do and I have my ID there. I can add a note if there is something to comment on, can be navigated to the assignment. But most importantly, I want to do a survey, or rather collect this data in a form at this assignment. So I am able to connect to my field data collection form. I go fill in details. When did I come in? When did I exit? The NCA permit number. I'm now on the ground. I select the inspection type. Is it due diligence or mandatory site inspection? Then I input the inspection ID. And what I need you to notice that since I already assigned this task and I put the location automatically is picked on my map, even as I use this form to fill in details about this inspection site. So this enables us to actually pick, or rather collect information on a very accurate location, because from my assignment, then I'm able to get my exact location where I'm going to collect this data. Then I'm able to key in some other details. And once I'm done, then I submit my form. And you will see that once I submit my form, then I am able to see these reports in another dashboard. But when we are in the field, we are able to see how many assignments or how many people do we have in the field? How many assignments do we have in terms of priority? Is it medium? Is it high? Is it low priority? We are also able to see the number of assignments that are given. We are able to see who is not working, who is on a break. We are also able to see how many assignments have been completed and how many have actually been assigned. So once I fill my form, then I complete my assignment. We are able to see that the number of completed assignments will increase. Then as I fill in my form, my inspection form, I'll be able to see on this particular dashboard right here, the field inspection report, in terms of what we were picking in the field. I can see in terms of inspection types, how many due diligence types of inspections were carried out. At this point, we have 3. How many mandatory inspection types were carried out? We can see that we had 9, a total of 12 inspections that were carried out on that particular day or week, depending on how frequently this is updated. Then we can select by county, how many counties were visited. We had our crews going to Kwale, Nyeri, Kiambu, Nakuru, and Nairobi, and we can select Nairobi and see. In Nairobi, we had 5 number of inspections, and from our inspection report, we can see that we had 2 projects that had detailed signboards. One was missing a signboard, one did not, having a signboard was not applicable to it. And we can see that 2 projects did not have the OSHA documents. We can see that one had the barricade, and you can also see the safety signs at designated points. How many had, how many did not have, and so on and so forth. So at a glance, we are able to see this information at the back office, and by and large, we are able to have informed decision making at the end of the day and take action. With that, I would like to ask if we have any questions. We can bring them forth.